Good morning, everyone. Thank you for joining. We'll just give it a minute or so to allow people to join as they all filter in as the numbers go up. Okay, the numbers seem to be stabilizing. So welcome everyone, and thank you very much for joining us this morning. It's really wonderful to have so many people on this webinar as part of Net Zero Week. Just very quickly to introduce myself. So I'm Mark Sommerfeld, UK Director for the Carbon Capture Storage Association. We're an EU-wide trade body representing the carbon capture industry, and we advocate on behalf of the industry for a supportive regulatory and policy environment for the deployment of carbon capture and storage, as you would expect. Um, it's wonderful to be able to join you all today. This morning's webinar, we're focusing on where next for CCUS delivering industrial decarbonisation. So this question of the particular role CCUS has in helping industries to decarbonise, but go beyond that as well. This is about how do we support industries to remain here in the UK as well as abroad, and how do we support industries in remaining competitive within a world that is decarbonising, and how do we make sure that is effectively delivered? As mentioned, this webinar is being held as part of Net Zero Week 2026, which is the UK's National Awareness Week, sponsored by Balfour Beatty. So thank you very much for them as well. And during this webinar, we'll explore the role of CCUS in decarbonising UK industry. We'll discuss why industrial carbon capture is essential for maintaining UK manufacturing and competitiveness. And we'll hear directly from projects involved at different stages of delivery. Just briefly as housekeeping, we'll ask that you submit questions using the Q&A function. So at the bottom of your screen, there should be a number of things that come up, including a Q&A box. We have colleagues that are monitoring that, and I'll also be monitoring that, and we'll address those questions in the second half of the webinar. So we'll have the free presentations first of all, and then we will look to address those questions as well. For awareness, this is also being recorded for our note-taking purposes. With that, we'll move on to our first speaker. So I am delighted to invite Ian Walpole, who is part of Heidelberg Materials. So is one of the UK's leading cement manufacturers and the company behind Padeswood's carbon capture and storage project in North Wales, and one of the UK's first industrial carbon capture projects to reach final investment decisions last year. So really great to be able to talk about a project really in construction and getting underway within the UK. So I think with that, I will hand over to Ian and let him present his piece. Over to you, Ian.
Okay, thanks, Mark. And hopefully we get all the magic of PowerPoint working properly for us.
There we go. We can see that. Yep.
Okay. So you can see my full screen, can you?
No, we're still in PowerPoint.
Yeah.
But you want to go on to full screen?
I'll try that again.
There we go.
Is that good?
Yep, we can see that.
Okay. Okay, great. Thanks. Okay, so a bit of a introduction to Padeswood. Padeswood cement plant's been operating in Padeswood near Chester in North Wales for about 77 years now, started in 1949. And there's a very early photograph of the plant you can see there on the right. And we're basically working on a project to capture around 800,000 tonnes a year of CO2 from the plant, and expect to be operational in 2029.
Just to say, Ian, sorry, just had a note through the thing. So you are currently in presenter view. I don't know if you can take that off.
Oh,
If not,
no,
just
I wasn't intending to be in presenter view. We'll try stop sharing. I'm completely. You're getting to see all my slides. I think I've stopped sharing, haven't I now?
You have to stop sharing, yeah.
Yeah. It's a pain in the neck, isn't it? Right.
And if it's easier just to present a view,
Well,
then
you
I
have
think
my
go ahead.
slides if you wanted to just say next slide, but I'll try. I'll try again. What have you got now?
I've got your screen sharing of me, so not your slides.
You got my slides, full screen.
No, so we don't have your slides. You've just got a picture of me currently.
Yeah.
So if you go back to your PowerPoint slides.
Try something different here.
No, that's now your emails, I'm afraid. So you
That's
probably don't want to be
perfect. Well,
sharing that.
this might work. Has that
Oh, there we go.
worked?
Okay, you're still in presenter view, but I think let's just carry on for the sake
Uh,
of the speed. That's fine. Thank you.
how about this?
So we can, there we go. Perfect. There we go.
Perfect. Get there in the
Wonderful.
end. Right.
Great.
Sorry, I've used about 5 minutes of everyone's day up now. Okay, so I've introduced Padeswood, so from 1949 there. I think one of the key things for us in the cement industry is that we need carbon capture and storage to fully decarbonise our process because around 68% of our emissions come from the limestone we use as a raw material. So even if we took all our fuel, fully decarbonised it, convert it to hydrogen, we'd still have around 70% of the emissions from the process. So basically, CCS is essential for cement decarbonisation. So here's a quick overview of where we are today with the Padeswood plant. So you can see the photograph of the existing cement plant there, and this sort of shows the various development areas we're working on. So the CCS plant itself will be in the sort of southwestern corner of the existing plant. So you can see the sort of dotted white line is our site boundary, and that plot area is roughly similar size to the main sort of heart of the cement process. And a few things where we've got some innovation we've had to do around carbon capture for ourselves. So, we're including a CHP plant, combined heat and power, because we don't have a sufficiently large grid connection in the area. And when that will be upgraded to provide the necessary power, we'll be waiting another 15 years from today at least. And also, there's insufficient heat available on site to operate the process. So, a quick overview of the project as it's developed from the sort of 3D model. Very quickly, we were saying we were using amine carbon capture. So, run through, we take the gas from the kiln line through the CHP into a quench tower, absorber tower, and a water wash tower, an acid wash tower to remove emissions. Then the gas flow goes back up to the stack. The separated CO2 from the amine is then released in the regenerator column through the compressor and out through this area here into the CO2 pipeline. And there's various other systems you see around here, things like amine storage, water storage, water treatment, cooling towers, and so on. So it's a huge installation compared with the existing cement plant. Got a bit of waste heat recovery around the system as well, and water treatment before discharge to the river from any surface runoff. So a little bit of history back through sort of the project timeline. We started out in doing the industrial decarbonisation challenge as part of HyNet in 2021. At that point, HyNet was selected for track one cluster. So we went through the UK cluster sequencing process. It was shortlisted in August 2022. And at the same time as all this was going on, we were gradually progressing some of the engineering work. So at each milestone where we got some government approval, we felt comfortable to then invest further in the sort of starting feed and so on. So everything sort of moved in parallel, and we went through this sort of in parallel to doing the engineering feed. We did the sort of start the planning process and the permitting process. So everything was moving along with sort of almost three strands: engineering, government funding, and consenting. So basically, we got to about mid 2025, where all the pieces started coming together. We got our planning permission in April 2025. We took FID with government in September, and at the same time, the EPR permit was issued. And that basically gives us the point where we could then start moving forwards with detailed engineering, where we are now, and procurement and on-site construction work. So there's a little picture of probably about 3 or 4 weeks ago. So some of the sort of key bits around construction we've had to do. It doesn't look from the aerial photograph, but the actual plot the plant's being built on has got probably a 10 to 15 meter slope from north to south. So we're in the process of leveling that. On that area, we had overhead power cables and underground power cables, which part of our early works was diverting those. So all that was upfront financial commitment before we'd actually got to FID as well. So there's a fairly significant cost with that. And at present, we're installing piling for the sort of retaining wall at the north of the site and down the road. We've had 60,000 tons of aggregates delivered. We've had about 5.5 kilometres of newt fencing around the site because we had great crested newts in the pond you saw in the first photograph. And again, we're sort of everything working to schedule for commercial operation in 2029. One of the things I want to take the opportunity to say is that Heidelberg Materials, this isn't the first CCS plant. So we started operating our plant at Brevik in Norway in this time last year, and it is very different that the carbon capture plant's integrated within the cement plant. So it's a very sort of tight plot. But again, it's an amine process. So you can see the absorber tower here, compressor building. One of the differences between Padeswood and Brevik is we will be using a lean gas phase pipeline for storage. Brevik, it goes through a liquefaction process and ship loading and into the sort of Northern Lights storage system. So as a business, we've got experience now of operating carbon capture plant, which we're then building into our development at Padeswood. And then a sort of a final sort of point really around sort of net zero materials. So part of our Brevik process is we're producing what we called Evo Zero, which is the carbon captured cement. So customers are able to buy a fully decarbonised cement. Now, if you look at it, it's not too far from Brevik, which is on the coast, to import the physical product into the UK. But if we were, say, a construction project in southern Europe, in Spain, then shipping and trucking would increase the carbon footprint of the product significantly. So Heidelberg Materials effectively offer a certificated version of the Evo Zero. So cement's the same pretty much wherever it's made. Specification, the performance is all the same, but you can buy an environmental attribution certificate that effectively says you are now using net zero cement in your construction project. So for Padeswood, we are using Evo Zero for all the concrete used in the plant. So we're basically trying to minimize the whole life carbon impact of the construction and the future operation. And I think that's my 8 minutes well and truly used up, Mark.
Perfect. Thank you very much for that, Ian. As I said before, really great to see pictures of a site in the UK in construction and really underway. It's really exciting and also interesting to hear at the end there around Brevik and this certification scheme as well. That's also driving the sector forward, really demonstrating demand there for low carbon products as well and how that gets delivered. We've had one or two questions come in on the Q&A, but as I said, we will address those at the end as part of the Q&A session. So with that, thank you very much, Ian. But we'll move on to our second speaker, who is Jenny Sutcliffe, who's Government Affairs Manager at Phillips 66. Jenny works closely on policy and stakeholder engagement for the Humber refinery, one of the UK's largest refining sites, where CCUS is being considered for the future of the site. And I'll let Jenny describe what that looks like. So over to you, Jenny. Thank you.
Thank you very much for that introduction, Mark. I'm afraid that my video on my laptop appears to have stopped working, and it is certainly beyond my IT capabilities to work out why that is. So I'm afraid I'm going to be a sort of a talking black box.
That's fine. No worries. We can see your slides and we can hear you fine. So let's continue in that basis. Thank you.
Great. Thank you very much for having me and for that introduction. And thanks to everybody on the webinar for joining to hear about industrial CCS. Mark's already introduced me, so that's great. I will move on to an introduction of Phillips 66. So Phillips 66 owns and operates the Humber refinery, which is based in North Lincolnshire and has been supplying essential fuels and products, producing and supplying essential fuels and products since 1969, so more than 55 years. We have around 1,500 UK personnel. And what that equates to is more than for every person that we have working for Phillips 66, we generate additional economic activity in our local area and in the UK. And that equates to actually 6 jobs in the community. So really underscoring the importance and the economic contribution of the Humber refinery and really any industrial facility that operates in the UK. For those of you less familiar with Phillips 66, it is a US parent company, and we have a large refining and midstream and chemicals footprint in the USA with around 10 refineries operational. But in the UK, we have the Humber refinery, as mentioned. We also, our brand, our sort of marketing brand in the UK and the EU is the Jet brand, so kind of yellow Jet branded fuel stations, which you probably will have seen, most people will have seen, that's Phillips 66. I'll move on to talk about some more of our activities. We have mapped out a vision really for decarbonising our activities. The refinery itself has carbon emissions and a carbon footprint. And of course, the products that we make do as well. So we've mapped out a process, a pathway by which we could reduce up to 90% of our direct emissions through the use of carbon capture and through hydrogen. And we've also started to transition towards using renewable feedstocks, essentially waste feedstocks that will then contribute to a circular economy and reduce the carbon footprint of our products. We also make graphite coke at the Humber refinery, which contributes to the production of lithium-ion batteries used in electric vehicles. And so through doing all of these things, we can contribute to the energy transition and decarbonise our facilities. And we would also be connecting into local infrastructure, CO2 pipelines, hydrogen networks, and really becoming a part of a hub, a lower carbon hub in an industrial region. The Humber region where we are located is the largest industrial cluster in the UK, and we closely engage with many of the operators in that region to look at how we can deliver decarbonisation, how we can connect and make some of these projects really come to life. I touched on renewable fuels already in the waste feedstocks or waste-derived feedstocks. We have been leading in this since 2016, we started processing used cooking oil at the Humber refinery and have since grown that production to include processing of tyre pyrolysis oil. And again, this is providing a really important reuse for whatever otherwise would be materials that go for disposal. And in doing so, you reduce the life cycle GHG emissions of our fuels by around 80%. We were the first UK producer or processor of used cooking oil for renewable fuels. We are the only producer of development fuels, which are that more advanced feedstocks. And we're the only at-scale UK producer of sustainable aviation fuel and have had a multi-year contract. We have a multi-year contract that has been in place for a couple of years with British Airways to supply sustainable aviation fuel at Heathrow Airport. The Humber refinery also produces graphite coke, which hopefully you can see, or you saw the video of in that bottom right-hand corner of the slide. It looks a lot like coal, but I can assure everybody it's a highly specified synthetic material that goes into kind of a really important application. Historically, it's used as the electrode in electric arc furnaces, or the anode, or the electrode in aluminium smelting. So it contributes to those production of steel and aluminium. But recently, in the last decade, it has been used in lithium-ion batteries. So there's been a huge growth in use of this synthetic graphite for lithium-ion batteries. It forms the anode of a lithium-ion battery, and therefore you've got around 70 kilograms of this material in a typical electric vehicle battery, or it's also used widely in consumer electronics, so around 1 gram of coke in a smartphone. So these, of course, are really important products to enable the energy transition and the decarbonisation of transport. That was supposed to move on then. Okay. So then on to a little bit more about the decarbonisation of the production facility itself. We have been working on a carbon capture project and have completed the front-end engineering design, and that was with funding from UKRI in the Industrial Decarbonisation Challenge, which kicked off in 2021, and that FEED was completed in 2023. A phenomenal amount of engineering activity really that went into completing that FEED. And hopefully you can see the graphic, that video graphic, which shows a sort of virtual carbon capture plant there at the refinery. We went through the process of selecting a technology supplier and chose Shell's carbon capture technology for that. And we collaborate very closely with with Harbour Energy on their Viking CCS proposition, which is selected as a track 2 cluster in DESNZ's carbon capture programme. The initial phase of the carbon capture has been chosen for the Humber refinery's fluid catalytic cracker unit, which would be up to 500,000 tonnes per annum of CO2 capture. We also
Are you there, Jenny? So we've slightly lost you. Or at least I've lost Jenny. I'm assuming everyone else has.
CO2 emissions are a result of combusting fuel. For heat input into the process, hydrogen is an option as substituting the fuel for that heat demand. And we completed a study again with funding from UKRI on refueling the refinery heaters with hydrogen, and found that yes, they could be refueled with 100% hydrogen. And again, that little video shows the hydrogen burner on the right there in a refinery heater. This was on a test heater as opposed to one of the heaters on our site, but the right hand side is the hydrogen firing, and the left hand side is the typical fuel mix firing, which is a hydrocarbon based fuel. And just there's concerns, there's potentially concerns around flame pattern flame stability, and so on, which is important in these large-scale industrial heaters. And so doing these real tests provided assurance that those concerns could be managed and that it was feasible, that it is feasible to refuel our heaters with hydrogen. We've been working with Uniper and collaborating with them as they have got a project for 120 megawatt green hydrogen production facility, which is close to the refinery. And we would be potentially the sole off-taker for the hydrogen for that facility. And in doing so, that would reduce the Scope 1 emissions from the refinery, as we could replace some of that hydrocarbon gas that we use for heat with hydrogen. We also, just to kind of wrap up my review of our decarbonisation activities, we already engage very actively with our local community, as is so important for any industrial facility. And so we have apprentices. We have around 40 apprentices on site at this point in time. I think that 29 figure is maybe slightly out of date. And host many visits, engage in STEM events. And this is partly a community engagement and a learning and then building trust and collaboration activity, but it's also to try and tell the story of the refinery and ensure that people want to come and work here, want to keep coming and working here. That's important for the refinery as a base business, but it's absolutely essential for delivering some of these decarbonisation projects, which will require more people and skills to make them happen. I think that's a wrap up of my slides.
Wonderful. Thank you very much, Jenny. And really wonderful to hear about the range of activities that is going on at Phillips 66. I'm always amazed by the graphite coke example there, and thinking about this is something being produced in the UK and is absolutely critical to future technology and what we're building here, and demonstrating the benefit as well as all the other products that Phillips 66 are producing as well. Just a quick reminder to people, thank you for those who are raising questions in the Q&A box. If you can't find the Q&A box, you can go to the More button and it should be available there along the bottom of your screen, but we will pick those up after the next presentation. But our final speaker to hand over is David Parkin, Director of Peak Cluster. David leads on the UK's major industrial decarbonisation initiative, bringing together cement and lime producers to develop shared carbon capture and storage infrastructure. Peak Cluster aims to protect vital manufacturing industries while significantly reducing industrial emissions. I'll hand over to you, David.
Great, thank you very much, Mark. It sounds like you've just given my presentation for me. I don't know what I'm going to do for the next 10 minutes now, but
I know you, David. There's lots to say. Sure.
Yeah, always lots to say. Good. All right. Well, thanks to the CCSA for having me today. Good morning, folks. So I am the Chief Executive of Peak Cluster Limited. So we are a major low carbon infrastructure project, and why we're doing what we're doing. So I'll unpack this a little bit more later, but sort of probably two headlines to bear in mind as I go through my presentation. So firstly, in case you hadn't noticed, it is getting warmer out there. And it's getting warmer out there because we as society continue to emit vast amounts of carbon dioxide. The UK has done phenomenally well in reducing carbon emissions. It's probably one of the leading countries in the world. We've halved emissions in the last 25, 30 years. And we've done that largely because we've decarbonised our electricity system, but because we've also shut down a lot of industry in the UK. We still use a lot of stuff, but we buy it in from overseas, and then the carbon content of that does not sit on our carbon accounting. So we need to continue to reduce emissions in the UK if we are going to achieve our legally binding sort of emission reduction targets, but we need to do it in a way which preserves UK manufacturing capacity, UK industry, UK economic benefits, and that's fundamentally what Peak Cluster is all about. So let's pick up on the industrial piece to start with. So the UK uses and produces a vast amount of cement and lime. So I've heard a bit about this from Ian already. We use cement in all aspects of society. We build our schools, our hospitals, our railways, our power stations. Lime is a little bit less obvious, but is used across society as well. Everything from purifying drinking water to putting it in toothpaste, putting it in steel, putting it in agricultural products. So these are really fundamental foundational industry products. And yet we are struggling with cement and lime production in the UK. So last year saw the lowest level of domestic production in 75 years. And we have seen imports triple in the last couple of decades. Now, one of the previous industries I worked in for carbon capture and storage was the UK fertiliser industry. And many of you may be aware of this, but up until about 5 years ago, we had two major fertiliser production facilities in the UK. They both shut down. We now no longer produce fertiliser in the UK. Where do we get it from? Well, funnily enough, we get a lot of it through the Straits of Hormuz, and we all know what's happened there over the last few years. Last few months. So there is a real need, I think, to maintain domestic production capacity of some of our core products and industries in the UK. And I think there is a very real threat to the UK cement and lime industry that if we do not invest in it, then we will continue to see an erosion of production capacity. So what Peak Cluster is doing is in part protecting and supporting and growing our foundation industries, but in parallel, it is helping to decarbonise our hard-to-abate industry. So the Committee on Climate Change, which is the UK's independent advisor and sets the trajectory towards net zero, has been very clear, and they've said that there is no route to net zero without doing carbon capture and storage at scale. And they've said, for all the reasons Ian set out in his presentation, that it is particularly important in the cement and lime sector because there is no viable alternative at the scale which we need. And that is because the emissions come from the very process chemistry of essentially turning limestone into cement and lime. You heat it up, you drive off carbon dioxide, and that is the main source of emissions. So that is why we need Peak Cluster. What is Peak Cluster? So it is a, yes, ambitious, but we need ambition, bold project to capture carbon dioxide emissions from existing cement and lime manufacturing. I'm just going to move on to a pointer. So just bear with me a second. Yeah, so we're going to capture existing emissions from cement and lime plants across the Peak District. So Ian is over here in North Wales, but there's a lot of cement and lime production in the Peak District. Because the Peak District is beautiful, it's because of the geology, lots of limestone, and that's what you make cement and lime out of. Now, a lot of these facilities have been here for a long time. So Hope Cement Works, which is the biggest in the country, if you know the Peak District, you'll be familiar with the site. It's been there for almost 100 years. So in 2029, it'll be celebrating its 100th year anniversary. A couple of our other plants have been there sort of 50, 60, 70 years. Very, very well embedded in the communities. Embedded in the communities, not just from producing jobs and skills and wealth creation and sort of economic sort of output, but they're also very good stewards and custodians of the local environment. There is a lot of work goes into reinstating quarries, managing the landscape, and looking after that area very well. But they produce vast amounts of carbon dioxide. And one of the big challenges in talking about climate change is we quite often struggle to understand scale. So these three sites between them emit 25% of all the carbon dioxide across all of Derbyshire and Staffordshire. In particular, Hope Cement Plant produces 75% of all the carbon dioxide in the whole national park. So if you look at all the houses, all of the transport, all of the local industry, all of that across all of the national park, 75% of that comes up one chimney. So if you're serious about decarbonising entire regions, you need to do projects of this scale. So our existing cement and lime plants will capture their own carbon. They will purify it, compress it, and then put it into a pipeline, which is this red route. This shows our sort of current design boundary. We take that through Derbyshire, Staffordshire, across East Cheshire, West Cheshire, and then we sort of come up past Cheshire and then up through the Wirral. And then at the end of the Wirral, we will compress the carbon dioxide further, and then we will take it offshore in an offshore pipeline up to about here. I didn't put the right map in for this one, where we will inject it into depleted gas reservoirs in Morecambe Bay. They're currently producing natural gas, have been doing for several decades. But before that, those reservoirs held carbon dioxide sorry, not carbon dioxide, natural gas for millions and millions of years. So we're very confident in the geology and its ability to store gas under pressure. So the Peak Cluster Limited itself, so we have accountability for the pipeline, and the red route is made up of 6 investors. So we have 4 cement and lime companies. So Buxton Lime, Breedon, Tarmac and Holcim. So companies who normally compete with each other are collaborating to pursue a low carbon project. We also have Seal, which is part of the Japanese Sumitomo Group, Progressive Energy, who I work for. So we are jointly investing as well. And then National Wealth Fund, the UK-owned bank, is investing just under half of our development capital. So that is the project. And then obviously we work very closely with Spirit Energy, who are developing the offshore system. And they are the current producers of oil and gas, but they are moving into an energy transition company. So they are ceasing their hydrocarbon production activities and moving into carbon capture and storage. So how does it work? So we've had a really good explanation of the front end of the process from Ian. So we have an existing cement plant, and we build a carbon capture plant alongside it. That captures the carbon dioxide. We get a largely pure stream of carbon dioxide. Then we compress it. We run it through an onshore pipeline, which is what I'm primarily going to talk about today. We further compress it before it goes offshore, further pipeline, and then we bring it out to an offshore injection platform, and then we inject it and we store it in rock formations deep, deep, deep under the seabed. So the whole purpose of this, so the way we tackle climate change is preventing carbon dioxide from going up the existing chimney and into the atmosphere. And instead we're burying it for geological timescales, so in perpetuity, tens of thousands, hundreds of thousands, millions of years, and that is preventing that carbon dioxide going into the atmosphere and causing climate change. So we've talked a lot about the capture plants through Ian and Jenny, so I thought I'd talk a little bit about pipelines today, which is kind of my bread and butter. So, look, major infrastructure projects do impact a lot of communities. This is a significant piece of infrastructure. And quite rightly, local communities have got lots of questions about what we're doing. Is it going to damage the environment? Is it going to cause construction impact? How do we ensure that it's done safely? How do we ensure that we reinstate from an environmental perspective? All of which are very valid questions. So through our sort of community engagement, we're trying to sort of explain how this works. But one of the points I often make is there are already nearly 30,000 kilometres of high pressure steel gas pipeline in the UK used for conveying natural gas. We are, and they've been built over the last few decades with an exemplary safety record. They operate safely and reliably beneath our feet over the entire country. We don't notice them, we don't see them, and they're just there. So our project will very much look like that after we finish building it, but we do need to build it along the way. So what we do is where we're going to route the pipeline is we look to take a strip of about 40 metres in width, and we clear the topsoil away from that to give us a working width where we can move machinery up and down. We then excavate a trench. Sorry, I should be up here actually. So we excavate the trench, which is generally sort of only a metre or so wide, and we string up the pipeline along the sort of side of a trench. So that's bringing in individual sections of pipeline, 10 to 12 metres long. We get those welded and then we get tested on site. Then essentially they get dropped into the pipeline. We then backfill the pipeline. And then we test the pipeline. So we test all the welds as they go in, non-destructive testing, and then we pressure test the pipeline with water. So we expect any trench to be open for maybe sort of 6 weeks. So we're in and out quite quickly. This is essentially a mobile factory which moves through the landscape. I say mobile factory, it's not as big as a factory. Essentially, it's a few JCBs, but we do need to maintain access to the working width because we move vehicles up and down there to avoid putting a lot of those vehicles on the road. So there is clearly construction disruption as we go. We do need to tunnel underneath some roads. We do need to close some minor roads. But as part of our planning process, we have to sort of agree all of that with the local highways authorities. That is all monitored very carefully. So we do look to keep construction disruption to a minimum. So the vast majority of our infrastructure is below ground, and for that we do not require sort of permanent land purchase. We take out a long-term easement, and then we can return the land largely back to its previous use. So farmers can continue to farm. So if you drive around the country today, you can sometimes see gas pipeline marker posts, which essentially show where there are pipelines underground, but all of those fields are farmed. There are some restrictions. You can't build over the pipelines. There are some trees you can't plant, but most normal fencing and hedging and normal agricultural activity you can do. But we do need a few other facilities along the way. So we have the carbon capture facilities, which is what Ian's talked about, the big major infrastructure for capturing the carbon in the first place. And then periodically, so about over our 200 kilometres, we've got about 4 what we call above ground installations. These are maintenance areas where the pipelines come out of the ground. Sometimes we change the pipeline diameter. Sometimes pipeline sort of spur connections join up to each other. But generally sort of 100 metres by 100 metres, chain link fencing, but fairly discreet. And then we have much smaller block valve stations about every 10 to 15 kilometres along the pipeline. We do have one facility along the pipeline route, which is an above ground installation with a compressor. That is a larger facility. It's about 7 or 8 football fields with a chimney. So that does have some visual amenity impact. And clearly we need to work with local communities to ensure we manage that appropriately. So I think just the last piece I just wanted to pick up on, and I sort of alluded to this briefly earlier, that, you know, look, this is fundamentally an environmental project. We will probably abate about 1,000 times the level of emissions that we will use in building the pipeline. So people often say, you know, what's your payback period? So the carbon payback period of this project is months, may even be weeks, because there will be embedded carbon in the steel and the concrete we use and the machinery we use. But fundamentally, we're doing this project for environmental reasons, but we do need to protect the environment as we go. So we are subject to a very comprehensive environmental impact assessment, which will be reviewed as part of our development consent order. We work very closely and we get advice from a whole range of regulatory bodies like Natural England and the Peak District National Park Authority. We need to manage our construction operations very carefully. And we are going to be a biodiversity net gain project. So we do a baseline assessment of the entire route. We map all of the biodiversity. We use essentially a government calculator, which we determine an overall biodiversity score for our project. And we commit to leaving that environment 10% better than we found it. So if we take out 100 metres of hedge, we have to put in 110 metres of hedge. If we take out 10 ponds, we put in 11 ponds. And we have to commit to maintaining that enhanced biodiversity for at least 30 years. So yeah, we recognise that we need to operate sensitively with our local communities and do these things well. And we very much commit to doing that. So a large, complex project. We are excited about it. It is a big undertaking. We are extremely heavily regulated from a safety perspective and environmental perspective, planning permission, land access. All of that is in train. We're about 1 year into our detailed engineering and consenting phase. I say detailed engineering, it's actually front-end engineering design. We will be seeking to apply for our planning permission late in 2027 or sort of early in 2028. And looking to take an investment decision at some point in 2029 to be operating in around 2032 to 2033. And I'll leave it there. I'm very happy to pick up on any questions.
Thank you very much, David. And again, really useful to hear about the update of the project and how things are proceeding. It's always wonderful to hear about construction plans and the amount of planning that goes into it as well. We now have about 15 minutes for questions, and thank you to those of you who have put questions within the Q&A. We'll try and answer a couple of them, and I've got a question just to close off at the end as well. I think the first question came in during Ian's presentation on Padeswood CCS, but I think probably also relates to others as well. So I'll direct it at Ian first of all, but if others want to come in and present their views, also useful. So we often see the business case as the main barrier to reaching financial close for CCS projects. Could you tell us more about the business case for this project? And as I mentioned, this came in during Padeswood presentation. Do you expect it to generate economic benefits once funding and support mechanisms are considered, or is it assumed that it will increase costs overall? So a question there about how are you thinking about the business case, the economic benefits it's also providing to the UK, and how does that affect costs as well? Ian, do you want to take that first?
I think obviously we did a lot of work through the development of the ICC business model and the grant funding agreement and so on. So, all that development work we did, we got to a point where we felt as a business it was an investable project, and there was things that needed to be changed in there, both in the business model and the grant funding agreements that are in the ICC that got us to that point. So, I feel as though we've sort of demonstrated by taking an FID and that the business case, has stood up to internal scrutiny within Heidelberg Cement, or Heidelberg Materials, I should say. And I think the other thing, probably the UK funding model compares very favourably with other ones as well. So there's a strong business benefit for us doing this.
We actually had, just to build on that, Ian, we had two questions in relation to that builds nicely, which appreciate you might not be able to directly give numbers on this, but roughly what is the levelized cost of carbon capture at the Padeswood CCS given the project, but also as part of that, how does that compare to the Brevik carbon capture project as well?
I'd rather not answer those just on sort of grounds of commercial competition.
That's absolutely okay.
Yeah. But yeah, I think there's the big difference between probably Padeswood and Brevik is the sort of the size of the plants as well. Brevik captures about half the CO2 from the process, but that's done using waste heat generated on site only. So we had to go down this route of CHP to get the power supply and the heat we needed. But we're able to then capture 95%. So there's definitely an evolution. Then you can see in the Heidelberg projects as well that everything we're optimizing as we go along. So I think the overall cost of CCS will come down to cement through these two projects.
Perfect. Thanks for that, Ian. Maybe if I can turn to Jenny as well, and just that question on how does the business case stack up? You've got a lot of different products potentially coming from P66, significant investment going to CCUS. Where does the business case and drive come from?
Yeah, thanks, Mark. I think that the government's approach, which is effectively doing this business model similar to how they've done it for the offshore wind industry, and that kind of helps to address the difference between kind of the costs of doing a project and what those investing in it will get as a return. So it makes it investable. And I think that government has done a really good job of setting up investable business models. I think it's still a challenge. The competitiveness of industry in the UK is a challenge. Typically in the UK, we do see high carbon costs and high energy costs. And industry does, it's variable between industries, but the fuel sector operates in a globally competitive market. And while higher carbon costs, you might think, do drive up the incentive to invest in reducing carbon emissions. Also, when companies are looking at relative costs in different jurisdictions, they will evaluate where they place those investments. So it's not necessarily simple. We're kind of trying to tread quite a fine line between increasing carbon costs and providing the incentives to invest in carbon capture, but maintaining the competitiveness of UK industry. I think it's really important how these first projects, such as Ian's carbon capture plant at Padeswood, how they go, and demonstrating those business models and that the investment is de-risked and that's reliable and the returns are reliable. I think that's really, really important. So Yes, it's a challenge. The investment case is a challenge, but I do think the UK does have one of the better propositions, and it's trying to maintain that and kind of lock it in at this point.
Thank you, Jenny. Just to build on that, there was a specific question that came in for you in relation to what is the impact of CCUS implementation in FCC operating costs? And I'm assuming, and do correct me if I'm wrong, but FCC stands for fluid catalytic cracking. Is that correct?
Yes, it does.
Yeah, there we go.
Well done. You must have heard me say it many times, but yeah, it does trip people up a lot. So I can't talk about specific costs. However, the main impact will be on energy costs. There'll be an increased energy demand for the heating and cooling requirements of the carbon capture plant, and for the compression. I think there was a question in there somewhere about the compression, but boosting the CO2 up to dense phase, which is greater than 100 bar of pressure, requires a fairly hefty machine and a fairly hefty energy demand to go with it. So it does have an additional cost. However, that's still, that's what needs to be kind of built into this investment case. When I think of it from from an energy demand perspective and the additional CO2 load of that energy demand, it's still a significant CO2 reduction. So the costs and the additional CO2 are there, but it's still worthwhile doing. So yeah, that's it.
Thank you very much for that, Jenny. David, if I return to you, so one, going back to that initial question of, how does the project costs stack? How do the business case stack up for doing peak cluster with all of those cement players involved? What is the overall driving business case for this? But then there's also a number of specific questions for the peak cluster, which we can also get into. But maybe just to start with that top level one first.
Yeah, look, I mean, I think it's a really good question. I think we should sort of probably start this with a back to basics on climate economics, which is fundamentally the world's greatest ever market failure is a failure to price carbon appropriately. So if you listen to Treasury, you would say that the cost of every ton of carbon dioxide in terms of the societal cost. And when I talk about societal cost, it is increased insurance bills, increased food costs, increased disruption, etc. Is probably between £200 and £300 a ton. The challenge which we face is we do not pass that cost on when we emit that sort of carbon dioxide. So we underprice the cost impacts of carbon emissions. So we're always having to play catch up and put in place essentially business models which allow us to close the gap because we underprice carbon. So the cost of doing something is more than the cost of doing nothing. So the way this basically works is if you're a cement plant and you emit carbon dioxide today, you put it straight up the chimney, you pay the ETS price, so the carbon tax. And I'm going to give you very, very illustrative numbers here. Please do not write these down. This is for sort of purposes of exploring a business model, but you'll probably pay about 50 quid a ton to put carbon dioxide up the chimney. And you pass that cost on to your consumers, so people who buy the cement. And if the carbon price goes up, all cement plants face the same carbon price. They will all put their costs up and that gets absorbed by the customers. And in an ideal world, the carbon price carries on rising ad infinitum until all carbon has disappeared from our economy. And that is how the model is meant to work. But the trouble is, if the carbon price gets too high, then politicians don't like it. It's inflationary, cost of living, etc. So the carbon price through various mechanisms is held lower than it needs to be because the cost of carbon capture and storage, pick a number, somewhere between £100 a ton, £200 a ton, let's say 150. So for my partners or for Ian to capture every ton of carbon dioxide, it's going to cost £150 a ton. So we're not going to do it if we only have to pay £50 to put it up the chimney. So government steps in and puts in place a support mechanism which pays the difference between what it costs us to capture the carbon dioxide and what we'd have to pay anyway for emitting it. And that's the carbon contract for difference. They're being used across Europe. They're used in the UK. The basic model is as the carbon price goes up and we all pay more for the carbon in our goods and services and we better reflect the societal cost of carbon, the amount of subsidy which government pays goes down. But right now, the carbon price is not high enough to fund these projects in of themselves. So we require a carbon contract for difference into our project at the front end to make it work. But the way it works is that all of the capital for building the project comes from the private sector. So for our project, Peak Cluster, to take all of the capture plants, the onshore pipeline and the offshore pipeline, it will cost about £5 billion of private sector capital. Our investors only get their money back when the project works. So if CCS doesn't work, or we don't capture at the right rate, or we don't capture as much as we said we were going to, we earn less money and we don't earn a return on our capital. So the risk, the operational performance risk and the construction risk of the project sits with the private sector. And it's only if it all works that we then get the subsidy payment, which allows us to earn a return on investment. So it is really quite a sophisticated model. And this is why we think that the UK has done very well in building this. But yeah, that's how the economics stack up for us.
Perfect. Thank you, David. Some more specific questions, and I might just group these together because hopefully they're quick to answer. But so is the CO2 injected in gas or dense phase after compression? And if there is a change in phase during the life of the storage life requiring change of hardware. So
yeah. So I was heavily involved in HyNet for many years, and we decided early on to do an onshore gas phase system. So we've applied the same methodology to the Peak Cluster. So that is different from Viking. So Viking a dense phase, onshore and offshore. East Coast, so out of Teesside is dense phase offshore. They've got a sort of a lower pressure sort of onshore collector system. But yeah, both HyNet and Peak Cluster are gas phase projects. So 40 bar. And then in later life, the HyNet project may compress further at the beach compressor and go dense phase offshore. I think on Peak, we will stay gas phase offshore, but there may, in later field life, need to be additional compression at the wellhead to inject in dense phase as the reservoir pressure goes up. But with the Morecambe Bay fields, we've got 1 billion tons of storage. They are very, very large fields, so you can continue to inject in gas phase for a long time before the pressure builds up. So yeah, we are a gas phase project because our view on the thermodynamics is if you're injecting into a low pressure reservoir from a dense phase system, which is 100 bar plus, you're cutting the pressure a lot. You get a lot of Joules Thomson cooling in the system. You need to inject a lot of heat energy into that. So yeah, we run ours in gas phase, and over time, yeah, gas phase requires larger pipeline diameters. So it very much depends on your system configuration as to what you choose. But yeah, we're a gas phase project.
Thank you for that, David. A final question for all three of you, just in the last 2 minutes, and to help us wrap up. But all of this is predicated on producing low carbon products and recognizing a need for us to be decarbonising. But we're also in a world now where net zero is increasingly coming under question within the public debate. How do we make sure, what do we need to be doing as industry? What do government also need to be doing to make sure there continues to be demand for these low carbon products in the future? Ian, if I can start with you on that.
I think one of the things, almost, if you think about our customer base, the government's one of our biggest customers, for infrastructure, roads, housing, whatever else. So they need to actually sort of put the money where their mouth is and pay for the decarbonised products. Apart from buy some cheap imported cement that does the same job.
Yeah, absolutely. And I mean, for reference, we recently had our EU conference, and that was a specific theme there of EU nations doing public procurement on this stuff as well, and something we need to be exploring in the UK as well. Jenny, do you want to come in on that question as well?
Yeah, so I would say we need to recognise the importance of our existing UK industry. 40% of primary UK energy demand comes from liquid fuels currently. And so we need to recognise that, and we need to do a better job as industry and government and associations and everybody in telling that story. And once we recognise its importance, then we need to make sure that it is competitive and stays competitive. Fuels industry are pushing and supporting and advocating for inclusion in the CBAM, as we aren't currently in the scope of the CBAM that's due to be deployed from next year. And then after that, once you've recognised the importance, once you've address the competitiveness, then we are in a good position, well positioned to support the energy transition and deploy carbon capture and the many other things. And hopefully then the public recognise also the need for those lower carbon products that will be delivered by carbon capture.
Excellent. Thank you very much, Jenny. And David, finally to you.
Yeah, I'd very much echo what Ian said. We do need government to be specifying low carbon products, and 50% of the cement used around the world is in government-backed projects. So it's not just the UK government; it is others. Do specify low carbon sort of products. I think the other piece, and this is unashamed of protectionism, and I'd largely thought the world had gone away from this, but I think in a world in which industrial sovereignty is quite important and industrial security. I think the UK can do more on specifying not just low carbon, but specifying British. So the UK has made some very helpful announcements just in the last few weeks on buying sort of British steel, ceramics and the like. I think doing that across the industrial base of cement as well would be very helpful.
Wonderful. Thank you for that, David. We have just overrun our time, so I will now bring it to a close, but to say a really big thank you to Ian, Jenny and David for their presentations and time today. I think it's really inspiring to hear about the progress that we are making on industrial decarbonisation and the role that CCUS has in delivering that. Apologies if we didn't get to your question within that. We only had 15 minutes at the end there, but there's some really useful questions to also be exploring. Slightly shameless plug here. If you want to discuss this more as well and maybe answer those questions, then do think about coming to the CCSA's conference in October, CCUS 2026. From ambition to delivery, which is on the 13th to 14th of October in London. Tickets are available online. If you just type in CCUS 2026 conference, it will come up. And as part of that, we also have our international awards going on the day before on the 14th, with nominations opening from the 14th of August. So with that little plug, I'll finalise, say thank you very much to everyone for attending and joining us today. I hope you found it useful. It's been a really interesting discussion, and thank you again to our presenters. Thank you all.
Thank you for having me.
Thanks, Jenny.
Thank you, Mark. Bye.
Bye.